Hey everybody, Brian here from quantlabs.net. I wanted to show you a very important video concerning Boost with Boost Python and C++ calling Python. If you've been following me for a while concerning my Python scripts in this algo trading course for running your own business, you'll notice I focus a lot on Python, which is pretty obvious. But as we move ahead, I'm trying to find efficient ways to have C++ call Python. Now, I've seen quite a lot of, over the years, Python community folks to try to beat or match the performance of C or C++ within a Python environment. That kind of, to me, is kind of crazy because you should be actually doing it the other way, where you have C++ embedding a Python script, but in that essence, that might not be a smart way to architect either. So one of the options that I have presented was Boost with Boost Python, where Boost Python would call and embed a Python function or set of scripts or functions in your C++. So when you come to this website here, or I just posted this a while ago, C++ Performance Common Wisdoms and Common Wisdoms. Does that make sense? Yeah, I guess so. But it mentions about Boost here, and as you can tell, this is very true about Boost, where there's the must-have Boost is already in the standard, and one thing you need to understand here is that it's a damn large set of libraries. So for me to just do one type of or one kind of functionality where you have C++ calling Python through the Boost Python, it's kind of overkill because I can't remember how big this is, but it is a huge library. So I've kind of come up with an alternative but even simpler way of doing it. It might not be the most intelligent way, but it can kind of work for me. And one other thing I want everyone to understand is that Boost will bloat your application pretty fast because of this, what's highlighted here. So you got to really minimize your use of Boost. So what I've done here is I've broken it up into two parts. And in my Ubuntu Linux here, what I'm doing is I've got one part. So essentially, I'm going to have a program, as explained here in this link from Stack Overflow, is to watch file changes in a particular folder. So what we're essentially doing is, with the kind of Python script that I'm writing, is you can run a Python script in as a separate function. You're not limited on the dependencies of that function for Python if you were to run it with Boost Python, for instance. So if you're going to call, let's say, using Boost Python with an embedded Python interpreter session, the question then is there any limitations if you were to call, let's say, pandas or numpy functions from those packages? And it quite possibly could be. But if you're calling the Python scripts through a system command, so essentially you have a C++ program call a system command in Python, and then which would essentially call an independent Python script, that could work and alleviate the unnecessary need of using Boost as a dependency. So what I'm essentially saying is you could use the system command in C++ or C to call a Python script. Now, you might be thinking that might be a dumb way to do it. For certain use cases, it'll work, because if you're using, let's say in my case, you are using Python to, let's say, download data, or a convenient way to do some basic market metrics at a very low frequency, like once a day, end a day. This methodology could work. It may even work under a medium frequency as well. It just depends on the use case, but I would definitely not use this for more faster frequency, like even to a high frequency. You just be foolish to do that. But there is a way to get around this by calling a system command, call the Python script from that, and then wait for a response by, in most cases, the scripts that I have will, from Python scripts, will generate some kind of file. So most likely they'll create some kind of CSV, a comma separated value file. Let's say for downloading, as I said, from Yahoo. And if that's the case, you can use this link here, as I said, on Stack Overflow, where you can monitor a folder with subfolders and files inside. You can't do this one. You can't do this with subdirectories. It says here recursively, but you can use it to watch one level of a folder, but not the subfolder, and it would only watch for files that are created. So for instance, I'll show you that when you delete a file or modify a file, this program will not capture that. So here's the source code. Okay, what I've done is I've got 2 terminal sessions running, and one's a gedit, actually, session. It's a very simple script here. So here's the program in C++ that will watch that folder, and the folder we're watching is this TMP iNotify1. So if I load up my, show you my second terminal here, this is the program running, so I'll break that. So here's the folder that it's watching, or was watching. Let me just show you that. So it's TMP iNotify2, I believe, in this case. Let me just show you the code. So it's going to watch this folder here, as I said, TMP iNotify2, and we can compile it as we would. Just give me a second here. I'm going to get out of this editor session. And for those that are really new to C++, a good way to compile, very simple way actually, is I got this program called the C++ monitor program, which I just showed you. So this is the program, same source code is listed here. Okay, and basically what it does is it will watch the folder temp iNotify2, and if it sees that the file's been created, it'll print that out and notify you. And if there's a subdirectory created as well, that's all it's really going to monitor. So if I compile it using, let's say, G++, okay, so essentially it's just a straightforward link, including the obviously C++ file, and creates this bin file called AOut just by default, because I haven't specified what I want the name of the file. And that's it running there. So if I go into the folder temp iNotify2, which this program's watching right here, and I start doing things like, hey everybody, got the program AOut running, which is basically monitoring the, let's say, my iNotify1 folder in my TMP folder. So I'm going to make a new folder, call it hello2. So you can see here that got printed out. And I'm also going to create a new file. So I'll say ls and then create an output file of outl or something like that. So there you go. So it's working, as you can see here. And if I did the same thing with a Notify2, hang on here, let me just get into the proper. So on iNotify2, 2 is it? And if I did the same thing that I just did here, ls blah 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 fd, there you go, fd created, and maybe make a folder called sds, whatever. Okay, so that's that. More changes to come. Hey, Brian here again. I'm going to show you another example, actually a better example of calling a C++ program, calling a Python script. And basically what we're going to be doing is there's two things that we can do. First, let me just set this up properly. All right, so first thing, I'm going to show you the script that we are going to use. Now this is the Python script called create Python. So all it's really going to do is just open a file, an empty file called test file in this subdirectory here that I showed earlier in the inotify1, and where it changes is this error code. Okay, so I'm going to put the error code on a standard exit return of normal, meaning it ran okay. If there's an error, usually it's pretty standard that you might put an error return code of a non-zero, but for now we're just creating an exit code of 0. So what we've got is we've got another program in C++ that basically does calls the Python file, and what it does is this is a brain dead easy C++ script that hopefully everyone should understand. But basically right here is what we're running is we're calling the system function to run the Python interpreter on our system, and then at the same time run that previously shown Python script called create in Python. Now here is where it gets interesting, because as I said, the results is the exit code from the Python. So if it sees it is non-zero, it will print out an exit code of whatever we set it up from the Python. So as you can see here in the inotify path, we don't have that file that's created by the Python called testfile.txt. So what we're going to do here internally within C++ is run our Python script again, create Python, which is really just going to open up or write and create a testfile.txt in this folder, and that's it. And then we're going to also ensure that our exit code is 0, so the returning response from the Python will not get printed out at all. So it's just going to be, nothing's going to happen on that. So let's compile our C++ program here called Python. So by default, again being lazy here, it's called a.out. So we're going to run that. And what you'll notice here is it just created our testfile.txt, and when I said nothing gets created, or there's no error message printed out, that means that the Python did return a 0. Okay, so let's do a test here. I'm going to remove this file again. Move the trash, so there's nothing in there. So what we're going to do here is basically change the Python code. Instead of returning a 0, we're going to return a 1. So what will happen in the Python is the response will now be returning a 1. Because it's non-zero or not equal to 0, it's going to print out this error code or the exit code. Okay, so we can rerun our C++ program, which was called a.out. Now I just want to note, have people understand something here. This is a Python script, okay? So this is interpreted by the interpreter of Python, or the Python interpreter, which is called by this guy. So that's calling the Python interpreter when we run the system command, and then issue with it as part of the arguments that we're wanting to run the create Python script. From there, because it's being interpreted, we don't have to recompile anything. on the script because it's the Python interpreter gets called and will call this Python script create .py. Okay, so when we make a change here in the C++, we always got to recompile it with the compiler, as I did with this G++ command. Okay, just so everyone knows that. All right, so we don't have to recompile the C++ one, but we can just rerun it. Now remember, we've got an empty. That text file does not. That text file does not exist, and that's created by the Python script. And the other difference is we are returning a 1 and not a 0. So what will happen in the C++ side? It will print out this exit code was basically 1. Okay, so let's run on the terminal. So that will be that. So there you go. So you can see the exit code was 256 or whatever it was, and it created the file. Not sure why that would point out 256, but it could be something in the here, the data type. But nonetheless, it somewhat works, and it's a pretty good way to call Python and then have a response based upon the return and the result of what happens in your Python script. So hopefully that'll help you out, and it's probably the easiest way to do it instead of calling the the Boost Python as shown earlier in the first segment of how it's inefficient to call Boost.